This is a geometry lesson on parallelograms. First, we'll start with the definition of parallelogram. A parallelogram is a quadrilateral with both sides, a quadrilateral being four-sided polygon, with both pairs of opposite sides parallel. Okay, that gets us a parallelogram. I wonder if there's other ways to get it parallel other than just parallel sides. Well, let's see. Let's start with a four-sided figure here, a quadrilateral, and we know about this quadrilateral that the opposite sides are congruent, not necessarily parallel, but congruent. Purple's the same as purple, yellow's the same as yellow. Well, you know, if I want parallel, I'm going to have some angles. Well, if I had some triangles, that might help. Let's see. Okay, hey, you know what I can do? I can put this diagonal right down there, down the middle, and that'll make two triangles. And if they happen to be congruent, I'd be good. I'd be doing good. Made the shade with glass lemonade. Do they happen to be congruent? Let's see. Purple's the same as purple, yellow's the same as yellow, and red works for both. Oh, yeah. Side, 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 side. The two triangles are indeed congruent. Okay, so since they're congruent, that means this red-yellow angle is the same as this red-yellow angle. Oh, but wait. I can also think of this as the red as a transversal between purported or putative parallel sides yellow. So if the alternate interior are congruent, then the alternate interior converse means that the yellow are parallel. Yes! Okay, let's do it for the purple. Purple, the red-purple angle and the red-purple angle are congruent. The red acts as a transversal between the purples, and yes, indeed, alternate interior angles converse makes the purple also parallel, which means the opposite sides are parallel, which means we have shown this additional shortcutty type way to decide if they're parallel. Theorem, if the opposite sides are congruent, then it is a parallelogram. Next up, what if we know that two sides are parallel and congruent, and we're wondering if the other two sides are also going to be parallel? If I know they're congruent, and I know they're parallel. Well, you know, parallel, I want to put some yellow ones here, and I want to know if there's more than one way to put the yellow ones here, so that could I put them there so they're parallel or so they're not parallel? Is there a way to do it so the yellows will not be parallel? Well, let's think about what it means to be parallel. Parallel means they never intersect. They're in the plane. They never intersect. Okay, if they never intersect, that means they're always the same distance apart. Otherwise, they intersect. So if we can show that these two yellow lines are always the same distance apart, then we got it made. So here we have one with it drawn in. Okay, distance to a line is always perpendicular, so I've drawn in the perpendicular. Well, let's see. What I really want to know is if the distance is the same. But I can't measure it because I'm not allowed. So what do I do if I say, okay, look, I know that the yellow, that the red, pink are parallel. That makes the yellow a transversal. The pink are parallel. The yellow is a transversal. So that means that this angle, purple yellow, and purple yellow are corresponding angles. They are congruent. So in the triangles formed with the blue side, I'll have the right angle, the congruent, and the side is the same. Angle, angle, side. Angle, angle, side. Yes, these two triangles are congruent. Therefore, since corresponding parts of congruent triangles are congruent, the blue is the same as the blue, which means they are indeed the same distance apart, so that when I connect them, the yellow lines, being the same distance apart, will be parallel. And now I have the purples are parallel, the yellows are parallel. It is a parallelogram. Here's the theorem. If one pair of sides are congruent and parallel, then it's a parallelogram. Okay, next circumstance. here I've got, I don't know if this is a parallelogram or not. I'm just trying to show, again, if this is a parallelogram, if there's some kind of a shortcut that I can use. So is there a shortcut to tell me that this is a parallelogram? I do, however, know that the opposite angles are congruent. Okay, well, since they're congruent, I've marked them congruent, and I've labeled them with the same letter because they're the same measure. The others are opposite and congruent, and I've labeled them with the same measure, B, because they're the same measure, or same variable. Okay, now I recall that a quadrilateral has 360 degrees in it. We did that last time. So if I add all of the angles up, I'll get 360. So that's A plus B plus A plus B equals 360. Or I can write it simplified as 2A plus 2B equals 360. Divide everything by 2. A plus B equals 180. Oh my goodness. Therefore, angle A and B are supplementary. Why? Because the definition of supplementary is that they add to 180 degrees, and they add to 180 degrees. Oh wait, A and B are supplementary. Think of the top and the bottom as putative parallel lines, and this is a transversal. The consecutive interior angles are supplementary, therefore the top and the bottom are parallel. Now think of the sides as maybe parallel and the bottom as a transversal. Oh wait, A and B are still supplementary, and that means by the converse of the consecutive angles that these are parallel. So we got it another way to make sure they're parallel.
If you're in the building, please come to the front office. Eva Benzalo, if you're in the building, please come to the front office.
And here's the theorem that goes with it. Okay, next up will be, here's my handy dandy parallelogram. There we go. And I want to observe something about it. Since it is a parallelogram, the yellows are parallel, the purples are parallel. So since the yellows are parallel, I can treat the purple as a transversal. These are consecutive interior. So they're supplementary. Same deal over here with this one as a transversal. I can do the same thing the other way. Treat the purples as the parallels because they are. It's a parallelogram. And one of the yellows as a transversal. Oh my goodness. Consecutive interior are supplementary. Same deal up here with this one as a consecutive interior are supplementary. So you just get it all over the place. Everything's consecutive interior, and they're all complementary. Next up, let's try this one right here. Okay, I've got me a handy-dandy little parallelogram, and I've put in the diagonals. And I'm looking at that, and I'm saying to myself, that kind of looks like the purple crosses the blue one in the middle. And I wonder if it is. Well, I'm going to do a little measure here. The blue goes from right there to the middle. I'll mark it. I wonder if it's the same over here. Oh my goodness, it is the same over here. The blue certainly appears to be bisected by the purple. So the blue diagonal is bisected by the purple diagonal. I wonder if it works the other way. Let's try it and see. Okay, so that's to the middle of the purple. Oh my goodness, it works! Yay! Okay, so I've just demonstrated that in a parallelogram, the diagonals bisect each other. I wonder how I'd go about proving that. Let's see. Okay, well, if the diagonals are bisected, can I show that it's a parallelogram? Okay, well, they're bisected. That means the blue is the same as the blue. Part of blue is the same as part of blue. Part of purple is the same as part of purple. Oh, wait. This is starting to sound like one of those S's and A's theorems. I've got two sides, a side and a side, and a side and a side, but do I have an angle? Yes, I do. Looky there. Vertical angles are congruent, so I have side, angle, side, side, angle, side. They are congruent on the top and the bottom, and the bow tie, the hourglass top and bottom, the bow tie left and right are also congruent. What do I have then? Okay, well, I've got that the opposite triangles on the bow tie are congruent, which means their corresponding parts are congruent, which means blue-orange angle is the same as blue-orange angle. Treat blue as a transversal. Blue-orange are congruent. Therefore, by the alternate interior angles converse, we know that orange are parallel. Do the same thing for the hourglass top and bottom. We know that you treat the purple, either one, the purple as the transversal. Purple-green is the same as purple-green. Again, alternate interior converse. So we've got lots of angles, and therefore we've got lots of congruent angles, and therefore we've got lots of parallel lines. Two sets of parallel lines makes a parallelogram. There's our theorem. Here's a summary of the ones that we've just done to make sure that you've gotten them. Ways to show that a quadrilateral is a parallelogram. You can know it's a parallelogram if the opposite sides are parallel. That's the definition. You can know it's a parallelogram if both pairs of opposite sides are congruent. You can know it's a parallelogram if both pairs of opposite angles are congruent. If you have one pair of opposite sides that are both congruent and parallel, that's good enough to get it to be a parallelogram. Or if the diagonals bisect each other, that'll get it to be a parallelogram. Okay. Let's see how some of this works. How are you going to do that? Okay, this parallelogram, given that it's a parallelogram, the opposite sides are congruent, so x is 9 and y is 15. That wasn't hard. Okay, how about this one? Given that the one at the top. There we go. Given that it's a parallelogram, 6 would equal m plus 1, so m would be 5. N would equal 12, so n is 12. Here. The opposite angles are congruent. Opposite, so d minus 21 equals 105, so d would be 126. Z minus 8, the opposite sides are congruent, so z minus 8 is congruent to 20, so z must be 28. So when you subtract, you'll get it. We'll work around it and do these various things. Here's some more of them. Okay, on your exercises today, you figured out how to know the interior angles. So using that lesson from the last time, you'll know that the total is 540. Add them all up, see what's left over for the x. The diagonals are bisected, so 2y minus 1 will equal 9. 12 will equal x plus 3. Second week of algebra to figure out what that's going to be. Okay, and now a kind of a fun thing. Here we have a roller coaster, like at Astro World. I remember riding one. I'm not sure if it was Astro World or not, but I think they may have had one that's constructed like this. Okay, let's look at what this is. This is a parallelogram, and of course one of the main aims of making an amusement park ride is to keep people safe. Let's look at how it's constructed. What we know about it is that these opposite sides are both 16 feet, these opposite sides are both 38 feet. So we know it's a parallelogram. And if we don't change the length of the sides, like for example there's a bolt there on each of the corners holding it together, we're going to keep it the same. Notice that will always be a parallelogram. So if the people up on the top come down a little bit, it'll still be a parallelogram because the opposite sides will still be congruent. And that's what's going to happen with this ride. Here's the counterbalance, and it's going to go around, and the people are going to go around. It's going to be kind of like this with it. It'll come down and go through, come back like that, and then it'll do it again, and then it'll come, and it'll do like this. What's important to notice here is that since it is a parallelogram, since the opposite sides are congruent and remain congruent because they're bolted on that way, the place where the people are will always remain parallel to the ground. Why is that important? Because they're much less likely to fall out and they're much likely to ride safely. So, here endeth the lesson.